All right, folks, good evening. My apologies for having this pre-recorded. I don't like this asynchronous format, but my internet has been out for 4 days, and so I'm going to have to upload this file over a hotspot and hopefully get it to you by the time, sometime soon. First, you have a quiz today. Your quiz opens up at 7 o'clock, and it is open for half an hour, and I think you have a 15-minute time limit. It's 10 questions. They should be pretty straightforward. Good luck. Do that tonight. Yeah. All right. Today we're going to look more into Python code. I will be, since we don't have any interaction this evening, I'll do my best to think of questions you ask, and I'll try to show some code as well. After the lesson, I think tonight, I'm also going to do a second video. No, I'm not. I can't get online. I was going to say I'm going to do I'll do a second video of some coding challenges that with the fundamentals you'll have from last week as well as tonight, you should start to be able to understand what they do. There might be some parts or some logic that you don't understand, but I'll try to explain that as in detail as I can. There's a website called hackerrank.com, I think, where you can go and practice. You can practice writing code. They give you little challenges. They tell you the inputs and the expected outputs. This is where logging versus print comes into play and all that kind of stuff that we've talked about. But anyway, it could be fun. I enjoy doing that as part of class because I think it helps show how we break down challenges and start writing code. We did that way, I think, in week 1 for a quick, but you didn't know Python at all, so it probably didn't make any sense. All right, anyway, so moving into tonight's lesson. We were going to homework review, but we were not going to homework review tonight. But this last week's homework was challenging for some folks, but if you're watching this video and you want to go back and look at the homework again, you're welcome to. Remember, you can have partial credit up for an extra week. But the only file that really needed to be changed, your README file, just to change the URL from my repository to your repository. After you do that enabling of the actions for your repository. And then once you have those actions running and you'll see your badges, I think it was the HW1 file or homework1 file, was the thing that you had to change. And in those, the challenge that got some folks, the functions that like return the lowercase string or add 2 numbers and return the addition of those 2 numbers, they had input parameters in the function. And so those variables are usable by you in your code. So hopefully you've seen functions before and knew that. But if not, the parentheses after the function name has variables listed. You can use those. And also when you're calling a function like .lower or strip, make sure to have the parentheses after that, like .strip, left parenthesis, right parenthesis. That way you're actually calling the function itself. So it was maybe 6 lines of code you had to change in that file. So give it a shot again if you haven't turned it in and shoot for some partial credit because zeros really mess averages up. All right, so tonight we're going to talk about lists in Python, things we can do with those lists. And we're also going to start looking at Boolean values, true or false values, and how we use those within Python. And we'll see the if, elif for else if, else blocks, and how we can use that what's called truthiness of variables and evaluations within Python to perform more complicated logic. We can start building these logic trees of performing actions. So let's move through there. This is fun. So Python is meant to be a pretty language. It's meant to be very readable. It's meant to be very simple and understandable by anyone who understands Python. And so there's a Python package called this. When you import this, you'll get a little poem Beautiful is better than ugly. And the principles behind that in Python. Simple code is much better than complex code. Complex code is much better than complicated code, like complicated logic and things that are really low level and maybe it's hard to understand. Readability counts, meaning your variable names are important, your white space is important. The length of your lines of code should be short and understandable. Your functions should be small, all those things. And there should be only one and perfectly only one way to do it. It meaning the task you are dealing with. Now is better than ever. So now we're learning Python. Now we're going to write Python. So this is the Zen of Python. All right, lists. Lists are a ordered, we talked about this last week, an ordered collection of items. That collection does not have unique values. That collection does not have to have all data of the same data type. You can put anything in a list that you want to. And so in Python, lists are bound by brackets, so the square brackets. And then when you name them, following good naming practices, your variable names should indicate plurality. So if we're keeping a collection or a list of students, name your variable students. If we have customers, name it customers. A singular customer variable would be customer, but a list of customers should be named customers. And then dear, I try to be funny every now and then. Dear being. And so looking at some code, this small block of code here, our normal logging basic config. I'm not going to import this all the time. This is, you should kind of get in the habit of doing this every Python application you write. And so code samples coming forward won't always have this, but anyway. So we're going to create a list of bicycle manufacturers. And so maybe this is poorly named and it should be manufacturers, but whatever, the variable name is called bicycles, plural. And then I'm assigning the value of this, what I highlighted. So you'll see it's surrounded by square brackets, and there's a comma separated list of data. In this case, there are 4 strings. We'll see later we can do different data types. We can do all kinds of stuff. But in this case, I have a list of bicycles, bicycle manufacturers, Trek, Cannondale, Redline, Specialized. I was going to say something. Oh, I may accidentally say array. If you're familiar with arrays from other programming languages, it's the same thing, but in Python we call them lists. And so now I have a variable bicycles. The data assigned to it is a list. So now we can start think of what do we do against or for, how do we use a list? One of the most common things we do with lists is we need to figure out how long it is, how many items are in that list. So there's a top level built-in function called len, L-E-N, for length, to determine the length of a list. And so this is a string formatted debug statement. So my debug statement, if I ran this, would say length of bicycles colon %d, where %d will be substituted with an integer. And the integer is the return value of this function len bicycles. And so if I run this, did I have a Visual Studio Code? I think I do. Nope, I didn't open my VS Code, so let's do that. Whoops. So let's code in this directory. I will add this to GitHub after class for everything that I write. I did create a pip environment for us to use called in class. I'm going to create a new file. I will save it as first.py. And so here, I can copy this code, go back to VS Code. I'll maximize that for you, and paste that code. Let's see if I can make that a little bigger. There we go. Here at the bottom, I'm going to make sure I'm using the correct Python interpreter. I don't think I'll be doing anything with other libraries tonight, but I just want to, again, get in that habit of finding the in-class virtual environment I just made. There it is. So local share virtual environments in class. And so, no. Okay, so now I have this code, and I'm going to run it. And why didn't I see any output? Debug console. Python, code, length, logging, debug. Don't you love live demos? Did I forget to save it? I think I forgot to save it. Nope. I will pause my video now and figure this out. Well, that was quick, but super weird. I just put in a quick print statement, then took it out, and it worked. All right, so looking at the bottom here, when I ran it, you'll see my two debug notes, length of bicycles, 4, because there's 1, 2, 3, 4 items in it. And then I printed out the actual list of bicycles. And it looks like we would expect it to. It is ordered, so you'll see the order of items are the same as I declared it. All right, so you saw that I printed it. And so when you print or log a list, Python knows that you want to see it in a way that indicates first that it is a list, and second, you want to see every item in it. And again, indicate the data types that come out of it. So it is surrounded by square brackets when I print it. And the data elements inside are indicated as strings using the single tick around them. So you'll see I have 4 strings being printed. And so when you print a list in Python, Python returns a string representation of your list, brackets included. All right. So when we have data in a list, we need to get access to the data in the list. So we can do that a few ways within Python. As any other programming language you've probably seen, you can use what's called a subscript to access an item at a first element, or at a specific index. So if we think about these 4 items, they're stored by index. In Python, we always start counting from 0. Some programming languages don't. I don't know why, but C, C++, Java, Python, Go, I think Go. I don't know about Go for sure. Anyway, they start counting by 0. So it may be confusing at first, especially saying it out loud like I'm going to do. But to get the first item in the list, I have to use 0 as my index. If we think about left to right, like the English language, the 0th element, or the first element, the first item, 0th element, 0th index, is the furthest on the left. So 0 is Trek. So I can count Trek is 0, Cannondale is 1, Redline is 2, Specialized is 3. So index 0, 1, 2, 3. I can also say the first item, second item, third item, fourth item, but you'll notice, since I have 4 items, my max index is 3. So the maximum index, 0, 1, 2, 3, is always the length of the list minus 1. So if I have 10 items in my list, my maximum index will be 9. My first index is always 0, though. So to get the 0th item, I can use that subscript of 0 to get the first item in the list. I can use the first one the one index to get the second item. And when I get access to the items from the list like this, I'm no longer getting something related to a list. I'm getting a singular item. So we know there are 4 strings in this list. So when I access an individual item, I'm accessing a string. And so when I access a string, I can perform functions on it as if it were a string itself or a string variable. So I can call something like the title function. So let's take this over to my VS Code and we'll run this real quick. So let's paste that. And so here I'm pasting it from that interactive Python. So I'm going to remove these arrows. I'm going to remove my debug output because I ran that at a terminal to capture for the class. I'm going to comment I'll leave those up here. And I use the same list items. So here, I'll just add the code, the login code to the end to get the 0th element, the first element, 0th index, first index, and the title function of the first item with the index of. And I forgot to save it. Save, run. I do not understand why it is not all. Oh, it says I'm saved. There, now it's saved. There we go. So I got Trek as my 0th index, index 0. Index 1 is Cannondale. And then I called the title function on the item at index 0, which was a string with value of Trek in it. All right, cool. Let's move from there. So a list is a way we store a collection of data. We have created or we have initialized a list of bicycle manufacturers. We've accessed individual items. So that's the C in CRUD, create. We've read by using the indexes. So now let's look at updating and deleting items from our list. So a couple of things. I'm going to start a new list here. Honda, Yamaha, Harley Davidson. These are motorcycle manufacturers. And then I print out that list, and it looks like a list as we would like Python to tell us. Square brackets, ticks for quotes for the strings. Perfect. So let's change one of these. Let's update. We're going to update an item. So starting from the left, we're going to update the item with the index of 0, which in this case is Honda, was Honda, but I'm going to assign it a new value, Ducati. So the value on the right is being assigned because of the single equal sign to the space, the variable, the index, whatever word you want to use there, with the 0th item in the list. And so when we print out our list on the next line, you'll see our list has changed. Ignore that last A. I'm sure I copy and pasted something funny. You'll see the list has changed. So it no longer says Honda, but it says Ducati because I assigned the value Ducati to the 0th index in my list. What happened to it? Just went away. You can no longer get access to that data. That data, it's as if it never existed. There's no way to recover it. When you change the value in a list by index like this, you lose the data from the beginning. And so let's look at our list, and the len function that I showed before can be used on a whole bunch of different data types, not just a list. But Python knows how to deal with a list parameter to the len function. You can pass a string to the length function, and it'll give you the length of this as an example. So you can use it for a lot of different things. That's why it's a top-level function. Here, though, we're going to look at the append function for our list itself. So my list variable is called motorcycles. I need to call the append function on that specific motorcycles list. So the format for that is motorcycles.append and then I'm going to append a new value. I want Honda back. So I'm appending Honda. When I append something to the list, it adds it at the new highest index. So before I did this, before I appended Honda, I had 3 items in my list. Index 0 was Ducati, index 1 was Yamaha, index 2 was Harley Davidson. Remember, my max index is length minus 1. Length was 3, minus 1 is 2. Therefore, my highest index is 2. When I append something, it adds it at the new highest index. So we can think about it, it adds it to the right. So now I print out that newly updated list. It changes the list. It doesn't create a new list. It changes the list. So now I have 4 items in the list. Ducati at 0 still, Yamaha at 1 still, Harley Davidson at 2 still, but now I have Honda at index 3. Length is now 4, max index is now 3, so Honda is at 3 because I just appended it to the end of the list. Somebody new gets in line, they're appended at the line. So in this case, I got a new manufacturer at my motorcycle shop. And so I still have Ducati, Yamaha, and Harley Davidson, but now I sell Honda. I appended it to the end of my list. We'll talk about delete in a minute. Another way of doing this, so I'm going to flip back and forth on you. Here we are creating our list in code with hard-coded values. So my code has Honda, Yamaha, and Harley Davidson. And if I ever need to change that list, that original list, I have to change my code. Imagine, though, we had a database, and that database had all of this data in it, and I don't know what's in the database. So the approach I would take then is to create an empty list, and then get everything from the database and then append it all to my list. So this is kind of how you would do that without the database stuff, which we will learn in the future. But here I'm creating an empty list, motorcycles equals open and closed brackets next to each other. Again, the value on the right is applied or assigned to the variable on the left. Then from that empty list, I'm going to start appending values. So I don't have any indexes. I don't have any length right now. They're undefined because I have an empty list. My length is 0, and therefore I don't have any items in my list. So if I append Honda, visualize this, now I have a list with 1 item in it. So now my length has moved up to 1, my max index has moved to 0 from undefined. And so if I printed the list here, it would be a list with 1 element in it, Honda. Okay, so Honda is now at 0, index 0. I'll append another data point. I'll append Yamaha. My length is moving to 2. Yamaha is now assigned my new max index, which is 1, because 2 minus 1. And so left to right, I have Honda, then I have Yamaha. Then I'm going to append Harley Davidson. So I'm adding it to the right. So left to right, now I have Honda, Yamaha, Harley Davidson. Length. Now my length is 3, max index is 2. And this is what my list looks like if I print it out. Yamaha. Sorry, I can't read. Honda, Yamaha, Harley Davidson. Index 0, 1, 2. Length of 3, max index is length minus 1, so 2. So appending adds to the right. If for whatever reason, let's say we wanted to keep things in an alphabetical order, sometimes we would have to insert the item into an existing list. So next block of code, another, or I guess using the same list of motorcycle manufacturers, Honda, Yamaha, Harley Davidson. I'm going to insert a new item. So again, I'm calling a function on my motorcycles variable, motorcycles.insert. Pay attention to the format here. Index number comma, value. So before, Honda was 0, Yamaha was 1, Harley Davidson is 2. I'm inserting a new value at index 2. So when I do that, my new index 2 value is Suzuki, and Harley Davidson gets kind of pushed to the right or shoved to the right a little bit to the next index. So again, I'm changing the length of my list, but I'm not inserting at the new highest number index. I'm inserting it at whatever index I'm specifying. So if I wanted to put it at the left, I would call motorcycles.insert 0. Let's do that real quick. So we'll take that over to here. Whoops, make sure we're recording. We are recording still. Good. And we'll come back here. Okay, so going back to my VS Code. Let's get rid of this stuff. Let's do this. Logging.debug motorcycles. Save. Run. I'm debugging motorcycles, Honda, Yamaha, Harley Davidson, in the order that they are appended. So now I will do that motorcycles.insert at 2 Suzuki. Give myself a little note after I inserted Suzuki at index 2. Saved it and run. Honda, Yamaha, Harley Davidson. My note to myself after I inserted Suzuki at index 2, Honda, Yamaha, Suzuki, Harley Davidson. Now for the 0, if I want to insert something at the far left, at the first one, logging bug Indian motorcycles. Oops, wrong code. Motorcycles.insert 0. I think Indian's a motorcycle brand. Logging debug motorcycles, but I need a note to myself. Logging debug after I inserted in at index 0. Saved. Run. So Honda, Yamaha, Harley Davidson. Suzuki at index 2. Honda, Yamaha, Suzuki, Harley Davidson. Then I'm inserting Indian at index 0. Now I see Indian, Honda, Yamaha, Suzuki, Harley Davidson. And so I can insert anywhere in the list that I want to. All right, so that is inserting, not appending. So now we need to remove, remember the whole CRUD, create, read, update, delete. You'll hear that acronym all over the place in computing, whether it's databases, data files, whatever. Creating, reading, updating, and deleting. We'll talk about APIs in the future, like RESTful APIs. We'll hear that acronym again, so remember creating, reading, update, deleting, CRUD. And so, here's my motorcycles list. Back to just Honda, Yamaha, Suzuki, Harley Davidson. I don't want to sell Suzuki anymore, so I'm going to use this magic keyword, DEL, for delete, motorcycles sub 2, or second index. So I'm deleting the data at list index number 2. So then I print my motorcycles list out, Honda, Yamaha, Harley Davidson. Cool. So that's if you want to remove or delete an item by a specific index. Now, just like the update earlier, when we updated and changed the value at a specific index, we lose whatever was at that index. We don't have that data. We can't access the string Suzuki anymore. So there are other ways we can do this. There's a function called pop, which is used in computing. You'll hear the data structures of stack versus queue. So a stack, I always think about as like the coin thing in my car. You know, I push down the coins, or a Pez dispenser. I push down the candy in the Pez dispenser, and I take the first one goes to the bottom, the last one's on top. When I pop the one off the top, I'm taking out the newest. So it's the last in, first out, right? The last candy I push down is the first one I take out. Versus a queue, which is like a line at the movie theater. That's a first in, first out queue. First in, first out structure. The first person in line buys their tickets first. And the last person in line buys their tickets last. So you'll hear the word pop when we talk about stacks. And so what that's doing in a Python list is it is removing the value from the highest index. But in this case, the function pop actually returns whatever that value is that you're removing. And then you can assign it to a variable. So remember, it was Honda, Yamaha, Harley Davidson. Pop the last item, highest index item. It removes it from the list. And then I can assign it to this new variable called bike. You don't have to assign it to a variable. You can just remove it. But in this case, I'm assigning it to a variable. Printing out my motorcycles list is now Honda and Yamaha because I removed or popped Harley Davidson. And in my bike variable, I have the value Harley Davidson. So that's pretty cool. There's an optional parameter. We'll learn about parameters a whole lot, I think, next week. But there's an optional parameter. So it's the same pop function with an optional parameter where I can say, I want to remove whatever index number I want to. So it's very similar to the delete. But again, you can then assign it to a variable when you use pop. So here I'm removing the item at the 0th index, which was Honda, right? Furthest left, Honda. So now motorcycles only has Yamaha in it. My new bike is Honda. And my new bike is Honda because I popped the 0th element and assigned it to the variable new bike. Okay, so far we've one way, two ways, three ways of removing or deleting data from a list. I don't want to say the last way, but the last way we're going to talk about today is using the remove function. So here we have to tell the list what value to remove. It's no longer index number, but what value to remove. Create a new, my list only has the word Yamaha in it. If I create a variable, I give it the same. I give it the value Yamaha. And then on my list, I call the remove function. And if the value Yamaha exists in the list, it will remove it. In this case, it obviously did because Yamaha was last in my list. And so now if I print out my list, it's an empty list again. If you call motorcycles.remove or the list.remove with a value that's not in the list, nothing will change. The list will not change. So here I'm removing a specific value as opposed to by a specific index. And so one way, by deleting the actual value, popping the highest index number, popping a specific index, and then removing a value. All right, so those are four ways of removing data from a list. All right, let's say we want to order the list. And for whatever reason, we want to make something alphabetical. In this case, we'll do alphabetical because, again, we're using a list with all strings. I'm making a new list called cars. And I have BMW, Audi, Toyota, and Subaru. Notice they are not in alphabetical order. Audi would be first, Subaru would be third, BMW would be second, Toyota would be fourth. But right now, they're BMW, Audi, Toyota, and Subaru. Again, I print it. It shows me it's a list by the square brackets around it, and it shows me their string values inside the list. So we can call a sort function. So my list dot sort, and it will change the order inside of the list. So this is why I'm notating this as a permanent sort, meaning it's changing the actual list. So now after I call that sort function, Audi, BMW, Subaru, Toyota, this is a very generic sort. So the string class, a string knows how to sort itself compared to another string. It's alphabetical. Numbers know how to be sorted against themselves, numerical order. Not every class that maybe we'll make in the future or that we'll use knows how to sort itself. So sometimes you can see some funny errors if you have a list with multiple things, like some strings, some numbers, some other class objects. It'll say I can't sort this. But in this case, we're just calling the sort function, and it will sort these by alphabetical order. Cool. As we would expect, Audi is the 0th index, or the first item. BMW, Subaru, Toyota. We can also reverse it. So again, an optional parameter. This one needs a name. So on pop, the optional parameter isn't technically an optional parameter, but we'll talk about that next week. It was just a parameter. Here, this is called a keyword argument. We'll learn all about it. But the keyword is reverse. Think of it like a variable, because it's a variable. And you're assigning the value of true. So when I call the sort function, I'm passing a keyword of reverse with a value of true. And now the sorting algorithm knows to do it backwards, or in reverse. And so my ordered list is now Toyota, Subaru, BMW, and Audi in reverse order. So the natural alphabetical sort is, I guess it's an ascending sort if you think about the strings. So A being the lowest, B being the highest. We can go into ASCII charts and all that kind of stuff on why that's a numerical. It's really a numerical sort behind the scenes, but A has the number. So then the reverse, it's a descending sort. Toyota, Subaru, BMW, and Audi. But important part is that the reverse equals true is a keyword argument to sort this list backwards. So let's say we don't want to change that original order on our list, but we still want to have a sorted version of it for whatever reason. Like if we had a first in, first out queue for a movie theater line, but we wanted to print the people in alphabetical order while maintaining the original order, we can do what's called a temporary sort. So going back to our cars list, BMW, Audi, Toyota, Subaru, I can call a top level, Python level sorted function, passing the list as a parameter. And what that does is it returns a new list. So it's a different list, but with the values in the sorted order. And that way I can still access my cars, my original list, in the proper order. So I do this a couple times here just to show. From the command line, when I do sorted, parentheses, cars, parentheses, it's going to print out that list because the sorted function returns data. So I can also assign it to a variable. So I can have another variable called sorted cars, and I can print sorted cars, and it's in the sorted order. But I also still have my original unordered list or ordered by something else list. So I can maintain an alphabetical order in code as well as the original order in code. So this is where you might want to, could think about using this sorted function. You think the sorted function has a reverse parameter? Probably does. Other things. There are other functions we can use. So there's a reverse function. That is the same thing as sort with reverse equals true. We can do the length of the list, which we've talked about, which the return value is an integer. And you can apply that, or you can assign that to a variable. Now this is where it gets kind of fun, or I think it's kind of fun. Not only can you use the index of the list, like 0 for BMW, 1 for Audi, 2 for Toyota, 3 for Subaru, or after I sort it. Ooh, this cars. Yeah. I need to fix this code because it's confusing, because after this is all built on the original list, not the reversed list. So bear with me. I'll show you this in VS Code just because I don't want to screw it up. Oops. VS Code. Okay. So here we go. Paste. Get rid of these. Get rid of these. Get rid of these. All right, here we go. Isn't this fun? All right. This is why I'd like these debug statements, because now I'm just going to remove the length. I think that's pretty self-explanatory. So line 3 is my original list. BMW, Audi, Toyota, Subaru. Line 4, I'm printing out a statement saying I'm about to print my original list, and I'm going to print out cars. Then I'm going to permanent sort cars. Long debug permanent reversed cars. Already had that. And so now when I save this, I can run it. And whoops, I'm getting ahead of myself. So you'll see original list, BMW, Audi, Toyota, Subaru. Permanently reversed, Subaru, Toyota, Audi, BMW. Okay. Now, changing this based on what we were seeing. So now after here is reverse order. So, okay. If we think about the reversed order, is this. That's our reversed order. Subaru, Toyota, Audi, BMW. Okay. There's a back to where I was going by, you can go by index. So 0 in this case is Subaru, 1 is Toyota, 2 is Audi, 3 is BMW. That's cool. In Python though, I can say, give me the item at index -1. So conceptually that's kind of weird, but it's a way of saying give me the last item in the list. So here I can debug that. -1 last item in list. And I can print out that last item in the list. So, reversed list, Subaru, Toyota, Audi, BMW. -1 index, last item in the list is BMW. That's pretty cool. We already know we can access the first one by index 0. First item in list. And before I print this, I should see this to be Subaru, because Subaru is my 0th or first item. What did I do? Oh, I'm highlighting that and pressed play. unhighlight that and press play. 0th item in the list is Subaru. We knew that. We knew that would happen. Okay, but if you'll note, though, I'm just seeing the string value. Because when I access item by index, it's accessing one item. So another syntax we can do in Python is something funny like this. This is called a slice. So logging debug 0 to 1. Oh, nuts. I said I was going to save this. Oh, I erased all the other stuff. I apologize. I'll save this. Here I'm going to get, it's called a slice of the list. So watch when I print it. See the output there? Surrounded by square brackets. And now the string is surrounded by quotes. What does that mean? That means I just returned a list. Not just a single element, but a list. So the way I read this is, from the cars list, starting at index 0, give me one item. And since I have this 0:1, it knows to give me a list. So the colon really indicates to Python that I want a list in return. And that's why you see this. Okay, so if we do that again, oh, and I totally said that wrong. I said give me one item. That's not totally accurate. What is accurate? Starting at index 0, give me all the items from 0 inclusive up to index 1 exclusive. So including index 0 up to but excluding index 1. So the reason I notice that is now I need to say, okay, give me items starting at index 1 up to but excluding index. So 1, 3. So 1, 2, 3. So this should give me Toyota and Audi. Index 1 was Toyota. Index 2 is Audi. Index 3 was BMW. But I'm exclusive on 3. I don't want 3. So when I print this, I should get 2 items. Oops. If I save it. Toyota and Audi. Okay. Now, here again, I'm specifying essentially the ending index exclusively. Another thing we can do, which is not in the notes, but fun, I'm just going to do 1: logging.debug cars 1:. So I'm not putting anything after the colon. Again, remember this says Python give me a list. Starting at index 1, give me the rest of the list. So this is how I get BMW. Starting at index 1, remember Subaru was index 0, starting at index 1, 2, and the rest of the list up to BMW. And because I can, and I'm here, if I can leave the number out afterwards, can I leave the number out beforehand? So what do we think this means? Essentially the same thing as 0:2. So I should see Subaru and Toyota because I'm exclusive on index 2, which is Audi. Subaru and Toyota, just like I thought. So that's essentially the same thing as 0:2. All right, back to the slides. Oh, before I forget, I'm going to save that, and I'm going to do a new file for when we come back. All right. Working with lists. So we are going to talk about iterating a list. Iterating means get all the values from that list and do something with those values. Let's see. So an example from the book. We're going to talk about this soon. One day we're going to have fun and make a video game. It's kind of cool. If you think about a video game, the little characters on the screen are called sprites. Everything is a sprite. Your player is a sprite. The clouds in the sky, the bad guys, everything's a sprite. The way a video game works is it's an endless loop. So every time it loops, you do something. You interact with the user, you get the user input, you move your sprites on the screen, that kind of stuff. So that's a basic example of iterating all of the sprites and moving them. Other examples, if I want to print out all of the items in the stock market, the closing prices of the stock market, I need a list of the symbols in the closing prices, and then I need to iterate that list, printing it out. Same orders, inventory, whatever example you want to do. I consulted a friend of mine, and we both agree that 75% of computer programming is iterating lists. It sounds simple, probably is. But anyway, we're going to iterate through a list. So the way we do that in Python is we use a for loop. So the for loop construct allows you to not worry about how many items are in the list, and it just lets you say, here's a list, let's process every item. So here, now we have magicians. So I've gone cars and motorcycles, now magicians. So Alice, Pat, Pallavi, Sam, they're magicians that I care about. So the way we think about this, or we say this, or I say this to myself, for each item in the list, do something with that item. So for each item in the list, do something with that item. So here's an example. I'm just going to print out or debug all of the magicians in my list. So for magician in magicians, for each item in the list. The list is magicians. I get a variable called magician that will have a single magician assigned to it. So this is a loop. You've probably seen do loops, while loops, for loops, whatever. Other looping kind of constructs. What happens is this line of code, logging.debug magician, or whatever code is in this indented block under the for loop, gets executed once for each item in the list. So this will get executed once for Alice, once for Pat, once for Pallavi, and once for Sam. Then I finish, I'm outdented again, lined up with for, not indented under for. I'm going to log debug done. So let's run that code. Give me my logging thing. Whoops, not cut, copy. Save, okay. Magicians, Alice, Pat, Pallavi, Sam, run. That code got called once per magician. So each value temporarily gets assigned to the magician variable, and all I'm doing is printing it. We can do other things in here. In this block, I can whatever code I want to execute here. I should see that execute once for every item in the list. So think about this as a block. This is the next block. This is the next block. And this is the fourth and final block. Then when it's done, I debug none. So the thing at the bottom of the slides, the cool part about a for loop is that I don't have to change my code if there's 0 items, 1 item, 14 million items in my list. It doesn't matter. So let's say we have a students list that's empty. I can for student in student logging.debug. Is there a student? I'm making something up. Logging.debug student. Logging.debug done students. And for fun, logging.debug start students. So you'll see this is a pattern I use when I'm debugging my code. So I kind of give myself blocks. So I know I'm about to do something with students, and whatever happened should be done by now. So any debug statement in the middle was kind of in this for loop. So I'll press play. And you'll see I started students, done students. There were no students in my list, and so this code never executed. But if I put a name in there, a new value, run it again, now you'll see it debugged my name. It said, is there a student? Chris. So a for loop, I'm going to remove that because I think the important part is the empty list. So when you're looking back at this code, you'll see the empty list. So start students, done students. So that's what this is done. If I have a empty magicians list and I want to debug the magicians in that list, there are magicians to debug. There are typos in the book. If you are following, when I copied and pasted this from last semester, I didn't copy down what chapter this is from, but I'm following the book for this kind of stuff. There are some errors. There's some indents where there shouldn't be indents. There were indents where they didn't indent where they should have, and like in this case, there's a missing colon. I wasn't very explicit about that. So the for loop. What I'm highlighting is the for loop. This is the construct of the for loop. To tell Python that you're now going to go to the lines of code within the for loop, you need a colon. So pretty much anytime you are indenting code, like a subblock of code in Python, you'll always have a colon on the line before it. So we're going to talk about if blocks and if else kind of stuff. You'll see colons to kind of start to delimitate the sub blocks or the indented blocks of code underneath. So that colon is super important. So I think I found that missing in the book. All right. A lot of times we count. So another thing we do in computing is we count an awful lot. And so if I want to count from 0 to 10, I can count to 0 to 10. If I want to execute a block of code a certain number of times, there are a lot of reasons to do this, but in Python there's a function called range. And from the documentation, range generates a series of numbers. Effectively, but not technically, but ignore that part. So effectively, the range function returns a list of numbers. So going back to my for loop, for x means one of the items in this list, and this list is the result of calling the range function with the number 5. I will print out each number that's returned from the range 5 function. Now you'll see here, again, we start from 0. What it's doing is it's giving me 5 numbers starting from 0. So 0, 1, 2, 3, 4. So you can think it's exclusive or it's 5 numbers. Same thing. Starting at 0. So if you just call this function and assign it to a variable, you can kind of do that. I think on the next slide I show you how to do that, how to get it to an actual list, because it's like kind of like a list, but it's not really a list. But for this kind of code, you can think of it as returning a list or a collection of numbers, so we can print them out. So that might be confusing, but I'll show you that on the next slide. I think it's the next slide. And so range has optional parameters. Here I can say 3, 9, which just like our indexes earlier, starts at 3, up to 9 exclusive. So you'll see the highest number I got is 8, and I cut off down here. But the return is 3, 4, 5, 6, 7, 8. So it's exclusive. This here is from the Python documentation. What this is what the function prototypes are, or what the function signatures are. So there's one version of the range function that takes a stop number. So starting from 0, stop before that number, stop that many times. So that's what we did here, 5. The next one has 2 parameters, start and stop. So start, here I started with 3 and I stopped exclusive 9. And then a third optional parameter is called step. So by default, it returns numerical order. So 0, 1, 2, 3, 4, right? It's adding 1 to every number. So the step is 1. You can specify a different step. You can say step 2 to skip numbers, to say 0, 2, 4, 6, 8, etc. You can do 3 or 10 or 12 or whatever number is a step. So instead of getting numbers sequentially, you'll get, number plus step is your next number. Previous number plus step is your next number. Yeah, that's the way to say it. Just to clarify, you'll see that it says, rather than being a function, range is actually an immutable sequence type. Immutable sequence type. Immutable means not changing. Sequence is the magic word here. So if I do, like I said, call that function with the number 10, I can assign it to a variable x. There's another top-level Python function called type. You can use this to figure out the type of your variables. For instance, if you're querying a database and you don't know the data types coming out of the database, you can call the type function on a variable and it'll tell you what it is. So here it is of class range. Okay. If you want to get a real list from class range, from a range object, you can pass it to the list top level function, and the result will be a proper actual real list, as indicated here when I print out my list. So this is important to know, because if you think you're dealing with a list object coming from the range function, you're really not. But it's really not hard to turn it into an actual list. You just pass it to the top level list function. So here, instead of doing list range 10, I could have done list x, list parentheses and x, because I already had an x variable there. 601. Okay. If you're not confused, stay with me. If you are confused so far about lists in general, pause, go back, watch again. If you still don't get it, email me, and we'll do a quick recap next week. But here is what I always thought of as a super advanced Python thing that I didn't understand. I couldn't read it. I didn't know what the heck was happening, so I ignored it until I decided to read this book for the first time I taught this class. And in like chapter 2, they say, let's talk about what's called list comprehension. What list comprehension is, it's a kind of Pythonic way of performing actions on a list in one line of code. And going back to the whole Python code should be beautiful and easy to read, to me, the first time I saw this, it was not beautiful and easy to read until I actually understood it. And once I understood it, and also knowing that everyone who writes Python should understand list comprehension, I can't look at this like a complex thing. I have to look at this as okay, I really need to understand this thing. And so what this is doing, it's combining a for loop and creation of new elements, and in this case, and a new array in one line of code. From the book, list comprehensions are not always presented to beginners, but I've included them here because you will most likely see them as soon as you start looking at other people's code, and that's absolutely valid. So if you look at anyone's code for any Python application, you will see list comprehension being used. So let's look at it and we'll break it down because it's really not that difficult. Remember, we are creating a list using a for loop, and we're accessing and we're creating new elements in that list. So this is an example of list comprehension. Okay, so let's break it down. Range 1, 11. So start at 1, end at 10, right? Because we're exclusive to 11. So, okay, cool. I have essentially a list of the numbers 1 through 10. For value in list 1 through 10. Okay, this is a for loop, right? So for value in range 1 through 10. But there's no code after it. So this is the cool part. The code for it is actually before it. So for value in range 1, 11, the new value I'm creating is value squared. Combines the for loop and the creation of new elements. This is the creation of new elements, value squared. Now you'll see though, this is also surrounded by square brackets. So my end result is going to be a list because I'm surrounded by square brackets. So for value in this range, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, square each value. And so my end result is a list of those values squared. So 1 is the first iteration of this list, of this range. And in the new list, it's going to be squared. So 1 squared is 1. So then 2, the next value in this for loop is 2. 2 squared is the next value in my resulting new list. So then 2, 3, 4, 5, 6 up to 10. 10 squared is 100. So the weird part is that the code for the for loop shows up before the for loop. These can get more complicated. We can use them to create other data types and all that kind of stuff. But for this example, if you understand this, then every time we see list comprehension, you'll be a step closer. So we have a for loop for each value in range 1 through 11, 1 comma 11, so 1 through 10. We're going to do something. For each of those values, we're going to square them. And in the end, those will be stored in a list. So if you want to, take this code and play around with it. Maybe instead of using the range function, maybe just change that to a list. Let's try that. All right, that's second. Let's make a third. I need my logging stuff. I should probably memorize that, but my brain's not good at memorizing stuff. Thank goodness for Google. All right, so here I'll logging debug squares. So here I should see that 1 through 100. 1 to 100. Okay. Let's do that a different way. Capitalized equals values. Oops, sorry. This is how I'm thinking about it. I want to end in a list, so I know I need to surround this by list. For name in, well, I could use a variable names, or I could just write a list of names. Okay, so I wrote a list of names. So I'm keeping extra white space here just to kind of show you what's going on. So for name in list of names, that's not going to work, but and I'll show you why. But you'll see where we're going. I don't know what error message this is going to show me. Let's see. Invalid syntax. Okay, cool. So we have not finished our list comprehension because we're not doing anything with the name value yet. Let's just start then. We'll start with name. So what this should do is copy my list. So when I print it, it should say Chris, Tom, Joe, Susie. Chris, Tom, Joe, Susie. Cool. But let's capitalize them. Upper. So now, starting from my lowercase list, for each name, I'm going to call the upper function, and then add it to the list, so my list should all be capitalized. It's all capitalized. What else? I don't want to capitalize. I want to title them. Notice I'm chaining. This is a waste of resources, but it's still kind of funny. So now they're all titled. I didn't need to upper them because I just then titled them afterwards. So that's the same thing. So for name in the list, call the name.title function. So there's another list comprehension example. All right, let's see. 19 out of 35. I feel like we should get rolling. Okay, so now let's look at if statements. All right. Example code and output to talk about equality conditions, etc. We have a list of car manufacturers, and we want to print them out in title case. Title meaning the first letter is capitalized. Except BMW. Right? BMW is already an acronym, and so we need to just uppercase the whole thing. Make sure, guarantee it's uppercased. So, starting with our list, Audi, BMW, Subaru, Toyota, I'm going to do a for loop. For car in cars. If the car name, this local variable, equals, double equals, so equivalent to or equal to BMW, then we're going to print car.upper. Otherwise, we're going to title it. So you'll see here I got Audi, Subaru, Toyota titled, but BMW is uppercased. So think about this as a section of code. If car equals BMW, note the double equals here. If you do a single equals here, I think it'll do something, but not what you want it to do. Then, so if car equals BMW, or is equivalent to the string BMW, print car.upper. Print car.title. And that's how I say it. If this case, do this, else, meaning otherwise, print a title. Okay? Remember our Python in our colons and our indentation. So this is all within a for loop. So this indented code under my for loop will get called for each item in my list. Then I have my if statement with a colon at the end, a new indentation or a further indentation or more indentation. If it equals BMW, I'm going to print it out in upper. Outdenting from that print, surrounded by colon. Otherwise, else, indented, print the car title. So here you'll see I have two levels of indentation. Let's say this is 0 levels of indentation. My if and my else block are 1 level of indentation. And my two print statements are 2 levels of indentation. And this indentation should be 4 white spaces, 4 spaces, not a tab. So that's a very simple if statement, but combined with the else statement. The else statement is optional. Not every if statement has to have an else statement. If I only care about BMWs, I don't need that else statement. I can only print a capitalized BMW. If car equals BMW, print car.upper and remove the rest of the code. So else are optional. But again, every new indentation is preceded by a colon, or if statement or else statement is followed, and for loop is followed by a colon. What this comes down to, that equality or checking for equality of that string against the string BMW, we can think about that equality as a Boolean value, a singular Boolean value. So car equals BMW is a Boolean value that says true or false. If car equals BMW, car equals BMW is evaluated as true or false. Whether a statement is true or false, used to track conditions or statements. So here, just showing you that in Python, there's also a keyword, true with capital T, and false, capital F. Lowercase true is not a keyword. You could create a variable lowercase true if you wanted to, but that'd probably be confusing. But the keywords are capital true and capital false. So I can assign those to variables. I could also assign car equals BMW to a variable, and that would give for a false value. And so that brings us back to conditionals. So at the heart of every if statement is an expression that can be evaluated as true or false and is called a conditional test. Checking for equality. So we're checking for equality in this case. So look at the first one. I'm assigning a value. I have a single equal sign. I'm assigning a value. The second one, I'm checking for equality with a double equal sign. Does the variable car, the value of variable car, is it equivalent? Is it equal to? Is it the same value as BMW? So in Python, that's how we compare strings. That's how we compare numbers. That's how we compare a lot of stuff. Here, so that equates to or evaluates to true. Because yes, I have assigned the value BMW to car. Then I checked car against the value of BMW, and they were the same. So this evaluates to true. Next one, car equals Audi. Does car equal BMW? No. So false. Checking equivalence of a string is what we're doing here. They are case sensitive. So in this case, car equals capital A Audi. Does car equal lowercase Audi? No. False. So one way if you're trying to do a case insensitive match is you can always do something like lower each of them or capitalize each of them for case insensitive case comparison. There we go. All right, let me pause for 2 seconds. Class is starting in 15 minutes. I need to somehow send an email. So here we can also check for inequality. So double equals was checking for equality. Exclamation point equals is checking for inequality, making sure they are different values. What's happening is that exclamation point is really inverting quality comparison. So it's inverse. It's the inverse of the result. So in this case is requested topping, which has the value of mushrooms, different than or not equal to anchovies. And in that case, it's true because it is not equal to. Numerical comparisons. We have all of the numerical comparisons you could think of, greater than, less than, equal to, etc. We can do the same. Are they equal in value? Are they not equal in value? Is age less than 20? Is age less than or equal to 17? Is age greater than 15? Is age greater than or equal to 18? And how you use that in a for loop is in an if statement is something like this. Age equals 17. If age is less than 21, you cannot have a drink. And if I ran this code, it would say no drink for you. No drink for you. Straightforward. So I can do multiple conditions using and or statements. I think the only example here I'm showing is an and statement. So I have one variable called age underscore 0, 22, value 22. Age underscore 1 equals 18. So I can do something like if age underscore 0 is greater than or equal to 21 and age underscore 1 is greater than or equal to 21. In this case, it's false. But what we're doing here with this and or is we're effectively building a truth table, which hopefully you're familiar with a truth table. We can think about the first condition as the top and the bottom condition as the left. So in this case, age is greater than or equal to 21. Age 0 is greater than, so that we'll go true. And age 1 is greater than or equal to 21. That's false, so false. So true and, when I say capital and, true and false evaluates to false. If I put that in an if block, if age is underscore 0 is greater than 21 and age underscore 1 is greater than 21, that whole statement evaluates to false. So two trues, if I'm doing an and in the middle, two trues is true. A and B is true. If either of those are false, then the whole equation evaluates to false. And so the or truth table is a little different. You can think about this. The and is are both values true? Are both values to evaluate to true? Both values have to be true. Left and right, A and B. Left and right, A and B. If both are true, then the whole thing evaluates true. For an or statement, if either are true, then the statement evaluates to true. A or B, left or right. Hopefully that makes sense. Okay. And so here we have another statement. We can check if a value exists in a list. So let's say we have a list of requested toppings. I like pizza, mushrooms, onions, and pineapple. If mushrooms, well, again, this is a Boolean expression. So this evaluates to a Boolean value, true or false. Is mushrooms in requested toppings? So I look at requested toppings, and yes, mushrooms are there. Mushrooms in requested toppings is true. Bacon in requested toppings. Bacon is not in the list, and so that's evaluating to false. So again, more Boolean expressions. And so then if we want to see if something is not in a list, in this case banned users, Andrew, Carolina, and David, we want to see, is the user Marie banned or not banned? Not banned. User not in banned users is true. So now Marie can log in because she is not in the banned users list. Because Marie, the value Marie, does not exist in that list. And here's what they look like in if statements. We covered one earlier. Let's dive a little more deeper. The way we look at it is if some conditional statement or conditional test, then we do something. So in this case, age equals 19. If age is greater than or equal to 18, you are old enough. We can print you are old enough to vote. Notice the colon and the indentation. You are old enough to vote is indented. Now, here I only have one line of code, but on the next one, I can execute more than one line of code. It's all about indentation. So age is 19. If age is greater than 18, print you are old enough to vote. And then print have you registered to vote. They are both at that same indentation level underneath if. So they only happen if age is greater than 18 in this case, if that conditional test evaluates to true. We saw an if-else statement. So again, if this condition equals to true, age is greater than 18, greater than or equal to 18, you can vote. So if you're over 18, that indentation will execute, and then this will not. If you're over 18. If you're not over 18, these conditions will not execute, but these will. So in this case, age equals 17, if age is greater than 18, evaluates to false, because the age is not greater than or equal to 18, and so my else statement gets executed. And the stuff in this block do not ever get executed if age is not greater than or equal to 18. And again, remember, else blocks are optional. They do not have to happen after an if statement. But if they exist, they have to be after an if statement. And then we have else if. In Python, the keyword is elif. So here, if we think about some rules, if I'm under ticket pricing for a basketball game, I don't know. So if you're under the age of 4, tickets are free. Under, not under and equal to. Under the age of 4, tickets are free. Otherwise, if you're under the age of 18, tickets are $25. For everyone else, the cost is $40. So in this case, I've set my age to 12. So under the age of 4, tickets are free. If age is less than 4, ticket is free. Else, if age is under 18, tickets are $25. Else, your admission is $40. So think about this as a chain. You can, in an if statement, the else is optional. The elif is optional. You can only have one if statement per block, one else statement, but you can have 0 or more, so 0 or many elif statements. I could do a different message in this case for under 18, under 19, under 20, under 21. I would just have multiple elif statements. So an if statement supports 0 or more elif statements. Once one scenario is reached as true, the rest are ignored. Let me show you what that looks like. Oops. Okay, so here, as we thought, let's clear this. I'm going to run this. Age is 12, so I am not under 4. It is under 18. Your admission cost is 25. The else statement does not get executed. Now, if I want to be more specific, elif, age under 14, print student discount of $12. I'm making something up. Now here, if we think about this, age of 12 is under the age of 14, but it's also less than the age of 18. So when I run this, I'm only going to get the first elif statement that happens in order. So a student discount of 12, because age is less than 14 evaluated to true. Therefore, the rest of these evaluations were ignored. So that's something very, very, very important to know. Only one scenario is reached as true. The rest are ignored. Once one scenario is reached as true, the rest are ignored. If none of the if or elif statements evaluate to true, then the else statement happens. And so another way we can do something, if I needed to do something different, if in that last example, if the student was under 14, and then something different if they were 18 and 14, I could get confusing and do if it's 14 and under 18, do a bunch of permutations. But another way I can do it is just run multiple if statements. So here, if mushrooms in requested toppings, print added mushrooms. If pepperoni in requested toppings, print, oh yes, all the pepperoni. If extra cheese in requested toppings, print adding extra cheese. So in this case, my first if statement would evaluate to true because mushrooms are in fact in the requested toppings. Pepperoni would not execute because pepperoni is not in requested toppings. And extra cheese is in requested toppings, and so I would print that out as well. I would print adding mushrooms and adding extra cheese. And then since I'm unindented, outdented, I am printing finished making your pizza. So a quick way, this is we're starting to talk about the truthiness of variables. So if I want to check if a list is empty, there are really multiple ways of doing that. I could check the length of the list. I could say if len my list equals 0. Cool. Or I can even do it much simpler. If requested toppings, colon. So in the case of an if statement or a truth evaluation or a Boolean expression, whatever word you want to use, I can sometimes, most of the time, just check a single variable. So in this case, I can check a list itself. So a list, when evaluated in an if statement for truthiness, is true if and only if there are items in the list. So it's not true if it's an empty list. So in this case, I have an empty list called requested toppings, and I do an if statement. If requested toppings, then I'm going to print out all my toppings. Otherwise, meaning it's not an empty, meaning it is an empty list, print, are you sure you want a plain pizza? So if requested toppings evaluates to true if and only if there's something in the list. Using multiple lists. So let's say I have a list of available toppings and a requested toppings and all this kind of stuff. In this case, I want to make sure that you're only requesting things that are available. What I can do is I can do a for loop for my requested topping, for each requested topping in my requested toppings. If requested toppings is in the available toppings, print, I will add that topping. Otherwise, sorry, we don't have this. So I'm doing a for loop on the outer, on the requested toppings, and I'm making sure they're in the available toppings. If they're not in the available toppings, so I have it. Quick style guide. When you're doing an if statement, add white space. So if condition age space comparator space value. The word pass is a magic Python keyword that doesn't do anything. It's called a no op or a no operator. This is valid syntax, squished together like that, but it's ugly and harder to read. So add the white space. And that is it. Next week, we are going to talk about functions, dictionaries, tuples, and input and output. And am I going to assign you homework? I'm not going to assign you homework because I don't know if I'll be back online tonight or tomorrow even. So I'll be nice since you had a quiz tonight. No homework. Yay. All right. Thanks, everybody.